Hi everyone, Mr. Eric Kua here, founder of Mr. Chemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Hi guys, let me just go through a couple of questions from the recent chem bonding quiz in case some of you haven't really had the time to go through it. Okay, so the first question, right, we have boron trifluoride, aluminium fluoride. Okay, they've given you the chemical formulas. They say differ markedly in their physical properties. Melting point is negative 144 and 1291. Okay, so this should actually inform you that their structure and bonding is very different. Okay, first they want you to draw the dot and cross for each of these structures. So I think you have to go ahead and draw the dot and cross. Boron and aluminium, you have to remember, right? In your periodic table, there's only 3 elements, right? Beryllium, boron, and aluminium that will form electron deficient compounds. Okay, what do I mean by that? Electron deficient means that they do not have the octet configuration. Okay, so basically when you draw the boron, right, boron fluoride, you already know that boron has 3 valence electron, so it will form 3 single bond with the aluminium. So all you have to do, right, is basically just fill in the dot and cross for boron trifluoride, and you should get this answer. Okay, then for aluminium fluoride, right, is a little bit different because aluminium fluoride, if you look at the melting point, right, it is actually very, very high, which tells you that this is likely a ionic compound. So for ionic compound, obviously the dot and cross is different from covalent compound. So you got to draw it with with a square bracket. Okay, so I won't go into how you draw this dot and cross for ionic compound. If you're not sure, please drop me a line and yeah, basically ask me lah. Okay, then they say after you draw a dot and cross, right, deduce the structure and type of bonding. Already when you look at the melting point, right, it should already give you a hint that BF3 is a simple molecular structure, okay, because it has very low melting point. So high melting point, this one is an ionic structure, so we already know that. That's why we draw the dot and cross the way we do. Okay, structure and bonding, because they want you to give them both the structure and the type of bonding. So what is the type of bonding in BF3? So firstly, right, you got to talk about the intermolecular, between molecules. Okay, between the molecules of BF3, between molecules, yeah, must take note, between molecules. And then what is the bonding between boron and fluoride within the molecule itself? So I'm referring to these bonds here lah. These are covalent bonds. So 2 things you need to talk about. One is your weak ID between BF3. Okay, why is it ID, right? Because this molecule itself is considered non-polar. Okay, non-polar molecules give you ID. Okay, and then next up, you got to talk about the strong covalent bonds. So large amount of energy to overcome those, but they didn't ask us for that, so we can just skip that. So when you talk about melting point, right, we are simply overcoming the intermolecular forces. We are overcoming intermolecular forces, which in this case is your weak ID. Okay, we are not breaking the covalent bonds, yeah. Please don't say that melting point you're breaking the covalent bonds for simple molecules. Okay, so be very careful. There's two different types of bonding. Melting and boiling only breaks intermolecular. Okay, so the story is different if you have an ionic compound. Ionic compound, right, you have to break every single ionic bond. Okay, there is no intermolecular. Okay, so when I was marking some of the work, the students, right, identified that it was an ionic compound. Very good. Then after that, they went to say that, oh, large amount of energy required to overcome the strong force of attraction between molecules. Immediate wrong. Okay, it's not between molecules because there's no molecules here. Okay, so we got to be very careful when we're doing questions like this. The phrasing will get you into trouble. Okay, think very carefully before you write down whether you are, what type of structure are you referring to, and what are the bonds or interactions that you are breaking.